Hi, I'm Liao from National Zhengzhi University. I'm going to share our work, ElastiLinks. Handheld controllers are the common devices in VR. Force feedback is not only on, but also between controllers, like playing a shooting game using a ball and a slingshot. However, to achieve realistic force feedback, not only realistic force types, but also proper points of application of force are essential. A point of application of force, or also called a PAF, is where the resultant force is applied to, as we can see the red points in the figure. When pulling a ball, users perceive resistive force without torque since the positions of the PAF and the hand are almost the same. However, when pulling a slingshot, users perceive torque of resistive force since the PAF is above the hand on the controller. Therefore, a dynamic PAF on each controller is required for proper PAFs between controllers. Previous works majorly focus on various force feedback on instead of between controllers. HaptiLinks propose 3 mechanical breaks to provide force feedback between controllers, but with fixed PAFs. Some methods leverage the property of dynamic PAFs by moving weights to generate weight and shape changing illusions in VR. However, how force feedback with dynamic PAFs between controllers affects users' VR experience still waits to be explored. ElastiLinks consist of 2 controllers, tracks, connectors, and force links. Each controller rotates a track and moves a connector, where the links connect to the controller on the track. Therefore, the connector becomes a dynamic PAF and is able to provide different torque to the controller and the hand. Furthermore, ElastiLinks provide 2 common types of force feedback, resistive force and impact, based on our previous works Elastic VR and Elastic Impact, on the 2 links respectively between the controllers. With the 2 types of force feedback and 2 dynamic PAFs, ElastiLinks achieves realistic and versatile force feedback between controllers and VR. Here you can see how ElastiLinks work. The connectors with rotation and offset movement achieve dynamic PAFs. We first conducted a perception study to understand users' resistive force and impact level distinguishability between controllers, which is for a proper PAF study design. By adjusting the width of the elastic band between the controllers and the size of the ball hitting the controller in VR, the participants needed to match the visual feedback and the perceived force feedback best. The results show that 3 levels are distinguishable for both force feedback. We then performed another perception study to observe users' distinguishability of PAF rotation and offset differences for resistive force and impact respectively, which also proves the necessity of requiring dynamic PAFs. The participants adjusted the PAF position instead of the force levels in the visual feedback in this study. For rotation, we observed that 2 PAFs with the same rotation angle from the initial position but in the opposite direction were easily confused. Therefore, we computed the absolute values of the rotation data to remove the direction from the consideration for further analysis. The results show that the participants could distinguish the rotation of the PAF stimuli but not the torque direction. For offset, 3 offset stimuli are distinguishable for both feedback. Here are the results of the study. Interestingly, we observed that resistive force with a longer application time than impact has better PAF distinguishability. Finally, we performed a VR experience study with 3 applications. Different PAFs and force levels for resistive force and impact were provided in survival shooter game with bimanual interaction, fighting game with 1 controller grounded on body, and fishing game with 1 controller grounded in environment. 3 feedback methods, vibration, fixed PAFs, and ElastiLinks were compared. The results show that ElastiLinks have better realism, enjoyment, and distinguishability. In conclusion, this paper provides force feedback between controllers with dynamic PAF, explores users' resistive and impact force level perception between controllers, explores users' distinguishability of offset and rotation differences of PAF, and proves that force feedback with dynamic PAF from ElastiLinks enhances VR realism. Thank you for your attention.